Hello everyone, and welcome to my video on dimensional analysis, also known as conversion factors. Before you watch this video, make sure you've watched part one, which is the conversion in the metric system called, the metric loop chart. That'll give you the basics of converting between milliliters and liters or meters to kilometers by moving the decimal. This is the second part of a video series, which is converting between metric units and English units and vice versa. Okay, so this is part two of the video series. So I've got a couple problems up here to kind of do as a sample, and we're going to work through these. Now, first of all, at the top here, you'll notice I've got some conversion factors. So these conversion factors will always be given to you. You don't have to know that 1 inch is 2.54 centimeters, okay? Unlike the loop chart where you got to know where the milliliters and the liters are, these will always be given to you. And if you're in an AP class, these are not the limiting factors when you're doing dimensional analysis. I'll show you how to do that. So anyway, basically we're going to start off with one. The first two are easy one-step conversions. The last two involve a little bit more thinking. So let me make sure we can scroll down and make sure we have all four problems. Yeah, they're all there. Okay, so the first one says convert 15 inches to centimeters. So 15 inches is the English unit, centimeters is the metric unit. So you can't just move the decimal, you got to do a conversion factor. So you go up to the top here and you see all your conversion factors. And this first one in the top left is the inch to the centimeter. So here's the important thing you need to understand. A conversion factor, I can write 1 inch over 2.54 centimeters. Okay, I can write it that way, or I can write 2.54 centimeters is the same as 1 inch. Okay, that's a conversion factor. They're equal to each other. It's exactly saying, this is a really dumb analogy, but you get the idea. You know that 7 equals 7, so I can make it as a fraction. I could say 7 over 7 is the same thing as, guess what? I can flip it and put the other 7 on top. That's the same as 7 over 7. Kind of a dumb analogy, but you get the idea. So I can put 1 inch on top or 1 centimeter on top because they're equal to each other. Now, when you do these conversion factors, the important thing to remember, the golden rule to remember is you set up your conversion factors so that your units cancel out diagonally. All right. So if you set it up correctly, you always write down what you have, what you're given first. You write that down, and then you set your conversion factor in there that you're going to multiply by, okay, so that your units cancel out. So let's start off with what we have. We've got 15 inches. All right. So I write that. We put it as a fraction and we put it over 1. Okay. Now I'm going to multiply that by my conversion factor so that my units cancel out diagonally. Well, I want inch to cancel out. So if I'm going to cancel out diagonally, inch is in the numerator there, I got to find the one with inch in the denominator there. So I'm going to go with it set up that way. So I'm going to go 2.54 centimeters on top, and I'm going to put my 1 inch on the bottom. Okay, now when I multiply those, what did I say? Units cancel out diagonally. The inch is gone, and now I'm in centimeters. So you multiply the 15 times the 2.54, and you just got 1 on the bottom. So the math is pretty easy on that. You're just going to get 38.1 centimeters. Now, you're okay to leave it like that in most classes. If you're in an AP class, AP Physics, AP Chemistry, you need to pay attention to significant figures. Now, this does not determine the number of significant figures. It's the measurement. I'll say that over and over again until it sinks in. You measured 15 centimeters. That's got 2 significant figures. Your answer should only have 2 significant figures. Don't let this be your limiting factor, okay, in terms of sig figs. You look at your measurement. So the best answer in an AP class would be 38 centimeters, or in any college level class. And boom, there's your final answer. So 15 inches is the same as 38 centimeters. All right, here's another one. It's a one-step conversion. 130 pounds. You write it out. LBS for pounds. Okay, and we put it over 1. You always write that first, and then you multiply by your conversion factor. So we go up here. We want to know 130 pounds you want to convert to kilograms. So here's our conversion. 1 kilogram is 2.2 pounds. What do? We want the pounds to cancel out diagonally. So I'm going to put the 2.2 pounds on the bottom and the 1 kilogram on top so that my units cancel out. Okay, so 1 kilogram on top is equal to 2.2 pounds on the bottom. Make that lowercase. Okay, now my units cancel out diagonally. You multiply everything on top, everything on the bottom, and then you divide out your final answer. So 1 times 130, that's just going to be, let me clean that up there. Okay, so 1 times 130 is going to be 130 kilograms on top. And on the bottom is just 2.2. Don't leave it like that. Divide it out. So when you divide that answer out, you're going to get 59 kilograms. Okay, you notice your measurement had 2 significant figures. That 0 didn't count. There's no decimal there. 2 significant figures. That was not your limiting factor. Okay. All right, let's work a multi-step one. These are the ones that usually trip people up. But before we do that, let me emphasize something. I know a lot of people are saying, oh, I can just figure out in my head whether or not I multiply or divide. Yeah, that's fine on one-step problems. But let me tell you, you're going to need to know how to do this dimensional analysis method. Okay, when you get into multi-step problems, especially in AP chemistry, you'll do some stoichiometry problems that involve 4 or 5 steps, and you got to set up the whole thing. If you follow the rules, it's easy as cake. Easy as pie, whatever you want to say. But if you're trying to think in your head how to do that, you get confused and it gets really easy to mess it up. So learn how to do the method by canceling out the units diagonally, and life will be so much easier for you. All right, with that said, let's do a multi-step one. So we got 75 miles per hour, and we want to convert it to meters per second, something we do all the time in physics because our standard unit in physics for velocity is going to be in meters per second. Okay, so 75 miles per hour is your typical highway speed. So you got 75 miles on top is equal to 1 hour on the bottom. I'm just going to write HR for hour. Okay, you look at the top here, and we got a little problem here. You want to convert miles to meters, but there's no direct conversion. So what you can do is you can go mile to kilometer, and your answer will end up, when we're all done, being kilometers per hour. And then we'll use our loop chart to go from kilometer to meter. Okay, so I got 1 mile equals 1.61 kilometer. Okay, I want kilometer to go out, and I want meters to be on top, or kilometers in this case. Okay, so I set this up like this. So I got 1.61 kilometer on top is equal to 1 mile on the bottom. Okay, as you're doing these, cross out your units. It keeps things organized for you. Okay, so miles are now gone. If you were to multiply that together and get an answer, your final answer would be in kilometers per hour, but you want it in meters per second. So let's turn that hour into second. And if you look up above there, you can see that other conversion factor. Okay, we have, what do we have here? 1 hour is equal to 3,600 seconds. So think in your head, what's going to go on top, what's going to go on the bottom. So that hours cancels out, and I end up in seconds. And this one you're going to cross out diagonally all the way from here to here. Okay, so I'm going to put 1 hour on top here, so that hours cancels out, and 3,600 seconds on the bottom. So boom, I cancel out my units diagonally. Okay, now when I multiply everything on top and everything on bottom, I'm going to get a fraction. Okay, so that'll be 120.75 kilometers. And then on the bottom, I've got 3,600 seconds. Once again, you don't want to leave it like that. You're going to divide it out, and you get 0.0335 kilometers per second. All right, now you can use your metric loop chart, which you know already, that's on the previous video. If this is meter, there's kilometer. Okay, if I want to go from kilometer to meter, I'm going to go 1, 2, 3 loops to the right. So I go 1, 2, 3 loops to the right. It's kind of sloppy there, sorry. And my final answer is 33.5 meters per second. Okay, if you're paying attention to significant figures, that's your measurement, 2 sig figs. I'd round that up to a nice even 34 meters per second would be the best answer for that. Okay, so there you go. There's a multi-step problem where you have to use dimensional analysis and the metric loop chart. Okay, here's a chemistry one for you. Convert 3 gallons to milliliters. First of all, think in your mind for a second. A milliliter is a small unit. 3 gallons is a lot. Okay, so it's going to be a huge number. So you write down what you have. 3 gallons. I'm just going to write GAL for gallon. Put it over 1. Do your dimensional analysis here. You look up above, and we can't go directly from gallon to milliliter, but we can go from gallon to liter. And once we're in liter, then we can use our metric loop chart. Okay, so I'm going to do my conversion here. and I want gallons to cancel out, so I end up in this case, I'll end up in liters. So 1 gallon on the bottom is equal to 3.8 liters. Once again, why did I put gallon on the bottom? Because my units are going to cancel out diagonally. Multiply everything on the top, everything on the bottom, I get 11.4 liters. Okay. Now they wanted in milliliters, so you got your metric loop chart. Remember, your base here is your measurement without a prefix. It could be a meter, in this case it's a liter, and milliliter is this way on your loop chart. Remember that one? So if I'm in liter and I want to go to milliliter, I go to 1, 2, 3 loops to the right. So that's going to be 1, 2, 3, fill it in with zeros. You got 11,400 milliliters. Okay? Paying attention to significant figures. My measurement, that actually had 2 significant figures. I should make that 3.0, 2 significant figures. So make your final answer 2 significant figures. That's 11,000 milliliters. Be the best answer to leave it as just like that. Okay, so there you go. So we have 4 examples of dimensional analysis, both one-step and multi-step with the loop chart. So I hope that helps. Watch this as many times as you need to. Practice, practice, practice. It's something we use all the time in science. So I hope that helps, and have a great day.